did you know that there are certain geometric series where there's an infinite number of terms? I mean, take this one. Suppose we take the series 1 plus 1/2 plus 1/4 plus 1/8 plus 1/16 dot, dot, dot. And we don't stop. We just keep adding. It is geometric in nature, right? Because what do we do to go from 1 to 1/2 or from 1/2 to 1/4? What do we multiply by? 1/2 each time. To go from 1/4 to 1/8, we multiply by 1/2. This is a geometric series. But it's a special geometric series because if you think about it, when you divide by bigger and bigger numbers, so when you divide by 2, 4, 8, 16, the actual number gets smaller, right? The numerator stays the same, the denominator gets bigger, the number gets smaller, right? 1/16 is smaller than 1/8. 1/8 is smaller than 1/4. So you're adding diminishing terms, which means this could actually have a finite sum if you were able to add an infinite number of terms. That's a big if, right? You can't. But if you were able to, you could have maybe a finite sum pop out of here. So what we're saying is this. You can get the formula for adding an infinite number of terms. So here's your nth term formula. Sn is equal to a1 times 1 minus r to the n over 1 minus r. If n goes to infinity, in other words, you keep adding terms, the number of terms goes to infinity, then if r is a proper fraction between -1 and 1, r to the n goes to 0. And so the formula for an infinite number of terms, we'll call it S, becomes a1 times 1 on top, or just a1 over 1 minus r. So if you have an infinite series, this would be the sum of an infinite geometric series. And it works as long as r is between -1 and 1. If r isn't between -1 and 1, then the absolute values of the terms of the sequence will just keep getting bigger, and they won't diminish to 0, so you'll keep adding numbers and keep absolute value-wise, keep getting perhaps bigger and bigger terms. Okay, you guys, we're going to find the sum. This is an infinite geometric series. We're taking 1 plus 1/2 plus 1/4 plus dot, dot, dot. So first of all, we have to find r to see if it's a proper fraction, to see if it even does converge. So you guys already told me r you can find by taking one term in the sequence, say the second term, and dividing by the first term if it is a geometric sequence or series. This is a series because we're adding the terms of the sequence together. So of course you do get 1/2 for r. Now r is a proper fraction, right? So r equals 1/2. You should make a note. That is between -1 and 1. It's a proper fraction, which means that this series does have a sum. So the way we find that finite sum, we call that sum S. And the generic formula is you take the first term in the series, which we usually designate as a1, and divide that by 1 minus r. Okay. So what are we going to put on top? What's a1? So look at the series. What's a1? 1. So we're going to put 1 on top and divide by 1 minus r, where r was 1/2. Is it that easy? Yes, it's really that easy. I feel like I'm selling a food processor. Okay, in the bottom, what's 1 minus 1/2? So you get 1 over 1/2, which is the same as what? It's the same as 1 times 2 over 1, divide by the bottom fraction, multiply, you get 2. So believe it or not, if you take the sum of 1 plus 1/2 plus 1/4 plus dot, 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 that sum is 2. That's all we're saying. If you could possibly add an infinite number of numbers together, you'd get 2. Otherwise, it just as the number of terms gets bigger, the sum just approaches 2. Does that make sense? And you could try it on your calculator. Add the first 10 terms together, add the first 20, add the first 100, and you'll get numbers, a sum that approaches 2. You're going to see some other notation. It's not just going to be written out longhand. You're going to see the summation notation. This looks pretty much like the old summation notation, except what's the upper limit on the n? Infinity. But that's just saying, hey, add an infinite number of terms together. This is a geometric series. You know it's a geometric series because you have pretty much an exponential function that generates the terms of the series. 7/10 to the thing that gives away it's an exponential function is the n in the exponent, or something involving n in the exponent. It doesn't have to be n itself. It could be n minus 1 or something like that. So it is a geometric series. And in order to add the terms together, we need to use the formula for the sum of an infinite number of terms in a geometric series. Or an infinite geometric series would be a shorter way to say it. So that would be the formula a1 divided by 1 minus r. Write it down. Every time you use it, you'll have it memorized in no time. a1 divided by 1 minus r. So what's r going to be? You have to identify r and a1. So what's r? It's going to be the guy brought to the power of n. So r is excuse me, r is equal to 7/10. Now what's a1, the first term in the series, going to be? Yeah, you have to realize, okay, this n, the counter down here, the lower limit on the n starts at 0. What happens when you plug in 0 to generate the first term? 7/10 to the 0 power is equal to 1. So a1's 1. Okay, so we're going to plug in this formula for s to find s. What does that turn out to be then? S is equal to, well, on top, a1 is 1. On the bottom, 1 minus r is 1 minus 7/10. Now, one thing I didn't make note of, and you guys should be in the habit of making a note of this. Is r a proper fraction? Is it between -1 and 1? Is that a true statement? Yeah, r 7/10 is a proper fraction. Otherwise, this formula doesn't work, you guys. Does not work. So we get, okay, 1 divided by 1 minus 7/10. Yeah, if you think about it, 1 is 10/10 minus 7/10. That leaves 3/10 on the bottom. Flip and multiply, what do you get? 10/3. Now, sometimes we get caught up in the math and we forget about how crazy this is. We're saying that you can add an infinite number of terms together and get a finite number. That's what we're saying. It's pretty crazy.